Hey everybody, it's George Gomez from Stern Pinball. I hope everybody's safe and having fun with our pinball machines at home. Since we're stuck at home, I'm going to be doing a series of videos on things that you don't normally see. For example, how we prototype ramps and different design things. But today, I wanted to talk about one of the unsung heroes of our world, which is the Spike 2 system. Spike 2 is the electronic system that we've used in all the LCD games. So starting with Batman forward, this is the system that is the basis of everything we do. It's Spike that gives us the power to create all those amazing graphics that you see. And it's proven to be incredibly versatile considering how simple and not not extreme it is. So Spike is a networked system. That means that everything begins life with this guy right here. This is what we call the carrier. The big rectangular board is the carrier board. This small board right here that's attached to it with a giant heatsink is the graphics processor and the CPU. And right now it's just an IMX6 ARM-style processor. It's a Cortex A9 specifically running at 1.2 gigahertz. It's a dual core processor, and honestly, when you look at all of the things that we do, take a look at the variety of the games, the devices on the games, the video features, the diversity of the video features across the games, everything from a fully animated game like Deadpool to games that have a lot of video clips like Batman, all supported out of this tiny little board. So the next iteration of the system that you see, we're basically just going to replace this dual core with a quad core to give us more processing power to do more cool stuff. But that really begins to speak to the modularity of the system from the time that we designed it. So we know from a lot of experience that we're going to be inventing things that we haven't thought of yet, and we need to be able to adapt and grow the system. And Spike has pretty much done that. So, so we talked about the carrier and the CPU, and then there are these guys, the node boards, right? So you'll see that these are populated across the playfield. By the way, every board on the system has a network address, and this is always 0. And then the node board that's down by the flippers is always node 8. And the other node board, most of our games today, all of our commercial games are built with 2 of these. We call them core nodes. And the cool thing about Spike is that it's a modular and scalable system. So when you run out of horsepower with this, you just add another node. And you keep adding nodes until you do what you need to do. But most commercial games run on 2 of these. If you look at a pin, it runs actually just on a single node board. So a node board has a series of, it basically drives coils, lamps, motors, it reads switches. So a basic node board has 9 coils, 32 switches, 3 strings of general illumination, so 16 times 3. And 5 control lamps, and then an expansion port. The expansion port is really important because the expansion port allows us to add more lamps, more switches. So you see that anything on the network has these RJ45 jacks. So you come out of a node with an RJ45 cable, you go to the next one, and they get daisy chained along. So everything you see here on the desk is the basic Spike system that would probably be on a pro game. We'll talk about the differences between pros, premiums, and LEs in a minute. But so what you're seeing here is, like I said, the carrier and CPU, the core nodes. This is the cabinet node. The cabinet node's the same game to game, and it does exactly what you'd imagine. It deals with cabinet-related switches, lights, things like the shaker motor, ticket dispenser outputs, and just stuff like that. Then you've got the power supply. It's a switching 48-volt power supply that's in the back box, along with this guy, which is the power distribution board, right? So one really cool thing about putting these in the back box is that it allows us to essentially test the back box as a unit. And the nice thing about the real driver behind putting them back there was the fact that it really helped with our UL safety testing because all of the AC voltages are contained behind steel in the back box. It also helped when we moved the switch. Everybody complained about moving the switch, but the reality is that switch wire created a lot of noise. And so by moving it back there, we got rid of that. So our FCC radiation issues went away. And so the compliance guys, ULCE and FCC, were very happy with that design. So you've got that stuff in the back box. There's a manufacturing efficiency in being able to, by the way, test a standalone back box. That means you can take a back box, marry it to any cabinet in the factory, and be assured that even though it gets tested entirely as a game, once it's all put together, there's another level of redundancy in that you tested every component in the back box by itself as a function of the back box. The other boards that you see here on the table, this is representative of one of the LED boards that you see behind inserts, control lamps, if you will, right? So the control lamps, and this is, we have smart boards and dumb boards. So these little guys are dumb boards, dumb LED boards. We have other size dumb LED boards, and this is a smart LED board. And what all that means is that it's got these 8-bit shift registers, which allow this to plug into the expansion port on the nodes and allow us that level of control. Because if you remember a few minutes ago, I told you that we only have 5 control lamps on a core node. By the way, on a standard Italian bottom, those 5 control lamps are controlled by the Node 8 board at the bottom, and it's essentially the out lanes and the shoot again lamp. And so, all right, so you got smart boards. The dumb boards, by the way, all come back to a smart board. And if we need to expand, the cool thing about the node architecture is that as designers invent new devices, the new devices become nodes in and of themselves and get added to the system. So this guy is the node, the Batman TV set, right? And when I said, hey, we want to have a TV set that has a display, does these things, etc. And so we just made a node board. So this node board, by the way, will go into the inventory. And pretty soon, we have, over the course of a few years, we have shelf loads of very diverse node boards that do things that are beyond the scope of the basic system. Designers can grab them and implement them into games. And also, as designers invent new stuff, we'll just create new nodes. Another example of this is the Octogoggles node board on Ghostbusters, right? That's this little guy right here. So both of these are node boards that we hadn't anticipated when we designed the system, and yet the flexibility of the system allows us to design it and add it. So I was talking about this might be a And so now when you add one of these, it might be an LE. This guy right here is essentially a serial interface board that goes to the expansion port on the board, and this allows us to add even more lights. So you might see this on a topper. You might also see it on a playfield that has a lot of RGB lighting. And again, it's a modular component that gets added into the system. We call this, the SPY board. And in this case, it refers to the fact that it's a serial board, not a Stern Pinball Inc. Board. So this might be the entire architecture of, with the exception of course, there's going to be more control lamp boards of an LE, and then we also have 4 coil node boards. You might also find these on a topper. So, or in the case where, like I said, the modularity of the system, the fact that all these things plug and play, it's kind of like a Lego set. You add more stuff and you get more power. So, we kind of love that about the system. And really, the system has been the unsung hero of a lot of these games that we've done. All right, so let's talk a little bit about the power supply. I have seen a lot of people complaining about the fan noise that it makes, and I don't disagree. It's probably noisier than it needs to be. This is an off-the-shelf power supply when we gave the power requirements and the rest of the specifications to the power supply company, including a cost specification, this is the power supply they supplied. We're working on trying to find a power supply that fits all of the parameters of that are required in the games, that has a quieter fan so that these things don't make so much noise when the games are idle. By the way, the reason that they make noise is because of the fan speed, and the fan speed is controlled by sensors inside the power supply. And when we do the design of something like the back box, we send the proposed design, once we're feeling pretty good about the system doing what it does, we send the proposed design to a laboratory. And at this laboratory, they put it through a series of stress tests. And one of the stress tests that it passed is a test that imagines a game at a laundromat in Los Angeles with its back to a plate glass window, no air conditioning, sun beating down on the black surface of the back box. If the temperature of the air is 87 degrees, and the temperature inside your back box is going to be substantially higher, and yet the game has to run in that scenario. So the power supply, while it's noisy, it's also incredibly robust, and it manages to maintain a game in some pretty tough extremes, like the one that I described. And that's we basically do that to assure that it may not be a game in North America. It might be a game in South Africa. It may be a game in South America, and with a completely different environment that it has to operate in, yet it still has to work. So let's talk about the other thing that I hear a lot. I hear about, how come there aren't any fuses on the system? So we have something on here which is actually a lot nicer than a fuse, because not only is it more capable than a fuse, but it's a very modern solution to an old problem, and that is overcurrent protection. So a lot of things have overcurrent protection. A lot of consumer products in your life have overcurrent protection, and so what happens is that this an overcurrent protection circuit on this node board senses what it's seeing, and whenever it sees a fault, potential overcurrent, it basically shuts down in milliseconds, and it protects things like these FETs, these field effect transistors, right? So all these transistors, and so every coil output, every lamp output, all protected. The switches are protected up to the 48 volts that's available on the playfield. By the way, that 48 volts, the fact that there's only 48 volts in the cabinet around the playfield is also a safety feature for somebody working on the games. And the cool thing is, we'll show you a little video later on of us purposely shorting like a flipper coil. And you'll see that the really neat thing about it is, if that was a fuse situation, you'd have to go dig in your toolbox to replace that fuse. Let's see, other things that other things that I get asked a lot about. I get asked about the notion of some of the messaging on the display relative to faults in the system, and we have to do a lot of work there. There's no question. We are about to go into a development phase on cleaning up some of that stuff. The game actually has a bunch of built-in diagnostics, as you know. And those diagnostics can be better integrated into the display and into the system. So early on, we had a message that I've heard a lot of complaints about, the update unsuccessful message. If anything happened while you're updating your game, you'd get this message, and the message was an error. You didn't damage anything. Typically, if you just reset your game, or powered it down, powered it back up, the message would go away, nothing's damaged, you're back up and running. It was an error on our part where we put up the message not realizing how people were going to interpret the message. So no node board has ever been damaged in that situation. The node boards all have the system, when the system boots, it polls every node board. It says, where are you, who are you, what do you do? And it also checks the firmware of that node board. If it doesn't have the correct firmware, for example, you damaged something and you replaced it, it goes out and gets it and puts it on, and you don't know the difference. So the system has a lot of power to keep itself up and running, and it will continue to do so. One of the faults that I hear a lot from the service guys also is the notion of replacing LEDs with incandescents. Had a gentleman who thought that he could improve the lighting condition on a Deadpool mirror ball by adding an incandescent from one of the old Williams games. Not going to work. So it draws too much current. You're going to create an overcurrent condition. Spike is designed to run only with LEDs. All the current budget, all the power budgets in the game are designed around that. So when you replace an LED, please replace the LED with one of like kind. Hey everybody, so here we are at my Deadpool game. I'm going to show you the location of some of these features that we talked about. Here's the power supply and the power distribution board, and then of course all the AC, remember I said, was right behind steel, nice and safe. That's right there. Of course the LCD display and the speakers, which all come back to the carrier and CPU assembly, which is this guy right here. Of note on this guy, the RJ45 connectors, the SD card slots, and then of course the USB ports, which you use to update. Very soon, hopefully, you won't be having to use those ports anymore because the game will be Wi-Fi connected and you'll be able to download your updates. And then let's go to the bottom of the playfield. I'll show you some stuff there. All right, so now we're going to look at node boards on the playfield and some of the other boards on the playfield, and also the cabinet node, right? So the very first thing, right here's the cabinet node. And like I said before, it handles switches, coin door stuff, your shaker motor, anything that's related to the cabinet is going to that board. That board doesn't change typically from game to game. It's the same board for all the games. And now we look at the playfield, and remember I said that most games are done with 2 core nodes. And there's almost always one up here. This is the address 8 node board. And then this would be the address 9 node board. Topper nodes are typically 12. And the only reason we've left out those numbers in between is to have room to expand a potential board that we might invent that would be a standard, some new thing that will be a standard in every game, would occupy one of those other addresses. Those addresses, by the way, on the node boards are controlled by the dip switches that you see on the nodes. And then you have a smart board right here, like we discussed, with the 8-bit shift registers. And that board jumps up to the expansion port on this node board. All of these little guys, which are dumb boards, would go to one of the expansion ports on a node. I think that is pretty much the general overview on Spike architecture. And I hope you understand now a little bit more about the system and why we like it so much. It really has enabled an entire generation of amazing games, and it's about to continue to do that with sort of an evolution of it once we go to the quad core. And as designers continue to invent new stuff. So we'll show you some videos on how to replace, for example, the surface mounts, and we'll show you some videos on how to update the games. We'll show you some videos on the over-circuit protection and also how to detect faults with the games. But and then one of these days I'll show you some more fun stuff, like how to build ramps out of foam core and how to build ramps out of plastic, and how to rapid prototype stuff, and we'll show you some CAD stuff. We'll show you some sketchy stuff, and just the notion of development. So I think in an effort to help you pass some of this time while you're stuck at home, I hope you like these videos, and stay safe, and thanks a lot.